As you all are aware, the world is not the same because of the ongoing pandemic COVID-19. But science cannot be altered by the objects of nature. So, we are conducting this year's session on a virtual platform. We indeed believe that this would be an interesting and captivating session.
First, we would like to introduce the chair of the session, as well as the presenters who will be joining us today. The chair for this session will be Dr. Professor Kotelawala.
Professor Kotelawala earned his PhD in biological science from Illinois State University and maintains his research focus in areas like conservation biology, sustainable development, environmental science, ecology, human-wildlife conflict, and rental management. His known activism in energy sector makes him ideal to receive our distinguished forum that discuss seemingly unrelated topics like drug discovery and energy perspectives. Please welcome Senior Professor in Zoology at University of Colombo, Dr. Kotelawala, to chair the session.
Good afternoon, ladies and gentlemen. Let me warmly welcome you to this second plenary session of the International Research Conference of Kotelawala University. Because of the times that we are facing, I think we have to do a sort of a hybrid session. Some of our audience will and the presenters will be joining us online. We do have one presenter here and then a small audience here. But I guess we should not allow any these logistical issues a problem. We should go ahead and get on with this session. So basically, this session is titled Making Growth and Security Viable. I think this is in line with the thinking that this particular decade, that is 2020 to 2030, is defined as the decade of sustainability. United Nations have introduced 7 sustainable goals that every country must try to pursue and achieve. And in this sustainable development discussion, I think some of the key things that we will be looking at is sustainability in health, sustainability in energy, sustainability in usage of water, ending hunger, education for all. These are some of the key targets that we are trying to achieve within this decade to make this world a better place to live, a desirable planet for human beings. So we have today lined up in this particular session 3 presenters. Dr. Chowdhury will be joining us from Karachi online, and we also have Engineer Dr. Kotelawala here, who will also join us online. And we have with us here today Engineer Dr. Kotelawala, who will go live. So basically, Dr. Chowdhury's presentation will be looking at nature-based drug discovery, which is a very important area, again when it comes to this dialogue about sustainability in the sector. The first presenter will be Dr. Chowdhury. As I indicated, he will be joining us online from Karachi. Dr. Chowdhury is the Director and Professor of Bioorganic and Natural Product Chemistry at the International Center of Chemical and Biological Sciences in Karachi, Pakistan. Dr. Chowdhury is a very eminent scholar, and he has more than 1,000 papers for his credit. And the fact that he has done excellent work is reflected by the number of citations. He has such numbers more than 25,000. He has also the owner of 7 international patents, including 40 US patents, and he has 68 books and 40 book chapters ready. So, without further ado, may I invite Professor Chowdhury to give his presentation. You have 30 minutes to present your ideas.
Good afternoon, Chairperson, dear colleague I hope you can hear me properly. Can you? Audible and clear? Can you hear me properly?
Yes, go ahead, Mr. Chowdhury. We can hear you loud and clear.
Okay. Okay, good afternoon and thank you very much, Professor Dr. Devika Veerakon, Chairperson of this session. And I'm also grateful to KDU for having me invited to this very important conference. A very important topic, and was hoping to physically visit and participate, but unfortunately these are testing times and it's not possible. Hopefully soon we'll be able to have more of these contexts which we have established over the years. So what I will do, I will present to you in next 30 minutes what we've been trying to do in terms of research in the field of natural product-based drug discovery and development. Can you see my slides? Okay, I need to ask you because technology is often difficult and problems are not so uncommon. So I just want to ask you, can you see my slides here?
Yes, Dr. Chowdhury, we can see you very well. Thank you.
Okay, so what I'm going to talk about is what we do in this huge institution of ours in Karachi. It's called the International Center for Chemical and Biological Sciences. It is also a UNESCO center. And one of the core disciplines of this institution was in the field of natural product. Now I know that Sri Lanka is one of those countries with greatest biodiversity, which need to be harnessed for a variety of different purposes. And Asia has been the greatest source of drug discovery since ancient times. It is extremely important that we evaluate indigenous regional resources and practices and that enormous structural and chemical diversity. So if my slides are visible to you, you would be able to see lots of fascinating molecules which came out of natural products. Biodiversity is the outward manifestation of chemical diversity, and I can tell you that this landmass of ours, Pakistan, is a very diverse country, and we have been working with various disciplines to explore the potential of biodiversity in Pakistan. It's about 2,700 kilometer long country with from subtropical weather to Siberian climate, and in between we have over 6,000 plants. Now these 6,000 plants, a lot of them have been used since centuries for medicinal purposes. And what we have done was that over the years we have collected them in from different regions of the country along with ethnobotanic information. So plants were collected, literally thousands of them, through a systematic survey of valleys and villages and urban towns and deserts. and as a result of it, we have a very large extract bank, and this is perhaps the largest extract bank in the region because we collected a very large number of medicinal plants. This start from field surveys, we do lots of field data collection, and then from science to ethnobotany is all combined together. And from till the end, we do lots of clinical studies also. And today I'm going to show you some of our recent work by combining ethnobotanical traditional knowledge with the modern science. This is extremely important. This I have seen in Sri Lanka. Sri Lanka is my second home, so I visit Sri Lanka very often. I know there is such a strong tradition, almost unbroken traditions of the use of medicinal plants for a variety of different purposes. And equally important is that these plants and knowledge has to be converted into pharmaceutical product, and that requires extensive chemical, pharmacological, and clinical studies on plants. Over the years, we have been working in the field of naturopath, and we have been able to develop some agents to a level of clinical trials. For instance, isox. People will find that this is a molecule which is among the most prominent and potent developing naturopaths today, and this has been patented in various countries of the world, including USA. This is its second phase clinical trial, 100% naturopath from a plant, and now we have synthesized and formulated that by doing the pharmacy and it also. We are going to present to you a supplement which has recently been patented in USA, and open label clinical trials have been conducted. Now we are in the process of conducting this one and clinical trial, and this is organic disease. So we have done also work on leishmaniasis and other tropical diseases. Our work on anti-drug resistance reversal agents has been internationally recognized. So there are lots of patents which we have solicited from natural product based on this. It's not only in plant extract, but we do lots of chemistry. So we have this huge bank of something like 20,000 compounds, and these are pure, characterized natural products, and so there's some derivatives which we have done together into a bank system. It works like a bank, and we do lots of studies on that. We thought I'd show you some of the fascinating molecular diversity which we have discovered out of medicinal plant. For instance, here you can see a tritetrapartite skeleton, which is unprecedented, and within the discovery of, within 1 year of the discovery of this molecule, there were many groups which were trying to synthesize this molecule. Now, if you think of synthetic chemistry, it's very difficult to synthesize molecules of this nature as a cage-like molecule. And this is where nature provides you ideas. These are molecular templates. For instance, this is a molecule which is an indissolvable molecule with positive charge on nitrogen. And this was isolated from a very famous herb, which is called Nigella sativa black. So a lot of these interesting molecules have been isolated, and we were able to enrich for literature by incorporating lots of fascinating molecules came out of nature. This is same with the marine animals, and here is the molecule which is a diterpene with interesting molecular structure unprecedented before. So these molecular entities provide you opportunity of exploring their biological diversity. This is a extremely interesting molecule of library which we have isolated from a marine animal, and has now been developed into a cytotoxic agent, mainly synthesized now, but originally obtained as a natural product. This is a very interesting molecule with a long side chain, and this was also was a novel structure. This is a rescue technique which we have isolated from plant. have been shown that I really wanted to walk you down in molecular structure. I just want to tell you that even without doing lots of deep microbiology, one can develop agents from natural product. And this is a classical example of phenotypic screening in which we have taken dietary origin natural products and have developed a formulation which is now patented internationally against Parkinson. We understand Parkinson is an extremely important neurodegenerative disease. It's very common in many countries of the world, including Sri Lanka and in Pakistan. As people are aging, this disease is affecting lots of people. Molecular basis of this largely involve differentiation and depletion of the number of cells, neuronal cells that produce dopamine. And because of this reason, it is important that agents are developed, and so far there is no treatment available for it. So health supplement was developed based on dietary agent, and for that, for any work which involves the development of an agent which eventually be supposed to be used as a drug or as nutraceutical, one need to have a model. We have state-of-the-art excellent animal laboratory facilities, several of them, and we were able to develop our tensor model in Bristol very correct. So the Parkinson model is a very practical model, and this model is now used in the study and the development of anti-Parkinson drugs. This use scoring of different symptoms. It is a very tricky model because you can, by using time-lapse studies, cameras, you can determine how many tremors and other signs and symptoms of Parkinson appears in animals. And this is exactly where we were able to identify that by looking at this model, we can mimic a situation of this more like a human Parkinson type. So scoring was used for 10 scoring, and scoring from score 1 to score 8 and 10, this is progressive disease. So you can see that initial from tremor to very high level of debilitating body dystonia, so-called movement disorder, eventually to death. So this was developed as model, and I'll show you what we were able to do. But since this is pathological group, and pathological group means that no intervention was given to animal, and as a result of it, you can see that this is a score 8, where animal is not able to walk properly. All signs and symptoms of a severe Parkinson is visible. And then, so it's not self-limiting. And in this case, you can see the most important drug available so far for the treatment of Parkinson, which is called Cypant, which is a combination of L-DOPA and an agent which protect L-DOPA to be converted prematurely into dopamine. And here you can see there is an improvement in the signs and symptoms of Parkinson. What I intend to do is largely what this supplement was able to do. So this is score 8 of a Parkinson system, and here you can see that animal is completely debilitated. There are lots of triggers and other things. But in case of once this health supplement was given to the animal has been able to move forward, and the score has reduced from score 8 to 4 and 2. This has been an extremely important improvement because in many cases this herbal supplement was able to perform much better than the clinically available drug. So a lot of these studies were conducted, and with this now we are in phase 2 and phase 1 clinical trials, We have got the approval of the government, and this study is currently underway in different hospitals. About 300 of patients recruited for this purpose, and this study is currently progressing with excellent results coming out of it. And of course, lots of nutraceutical products were developed out of it. Now, one example which I wanted to present is of diabetes. Now, we all understand that there are lots of complications which are related to diabetes, but the reason of diabetes is largely related to beta cells. Beta cells of pancreas are the ones which produce insulin, and over the course of diabetic complications, what we see is there is a decrease in the mass of cells and function. As a result of it, the insulin production is depleted in both type 1 and type 2 diabetes. Pancreatic beta cells are extremely important, and so far there is no drug available which can restore the beta cell mass or suppress the so-called apoptosis in beta cell mass. This is a key approach which we have discovered. So currently the drugs are available for a variety of different purposes. For instance, metformin, increase in glucose uptake, and there are lots of microurea derivatives which induce insulin secretions and a number of other ways also. But loss of beta cell and function is the key reason. Because of that, the pathology of diabetes appears. Now, we want to study that, and this has been published in also very good journals, including PLOS ones and Journal of Bioorganic Industry and other. We have developed an absolutely wonderful model in which we have used beta cells and inserted those beta cells by using pro-inflammatory cytokines. We wanted to produce and mimic a situation in which the beta cells are induced to die by cytokines, because this is the mechanism which is known for cell depletion in diabetic patients. Also, as we understand, diabetes is largely inflammatory disease, and this chronic inflammation leads to decrease in the number and function of beta cells. What we have done was that we used 3 different cytokines, and combination of these 3 cytokines were used to trigger the apoptosis and beta cells. This was our model, and then by using this model, we have looked into a cellular level and molecular level what actually happens when we try to protect those cells against this cytokine-induced apoptosis. And for that, variety of different kinds of biomarkers have been used. For instance, cellular ATP level is an excellent surrogate marker for beta cell viability or cell viability of any kind. So if we can measure the ATP level, we'll be able to see whether beta cells are properly protected or not. And caspase 3, which is an extremely important enzyme in the apoptotic pathway, is overactivist. So if we can see that caspase 3 is reduced in the presence of natural product of synthetic compound, and we can see that apoptosis has reduced also. So a whole range of different kinds of biomarkers were actually used to see how natural products such as these can protect beta cells from cytokine-induced apoptosis. An extremely important approach, because if we can protect cells from apoptosis, then we can have a sufficient number of cells producing larger quantities of insulin. At least one kind of insulin production can be restored in response of glucose intake, and is therefore an extremely important approach. Now, I will show you just one example. This is Jimmy. Very famous people who work in the field of chemistry, they know that molecules like this are very much available because they are secondary metabolized of many plants. For instance, this molecule has been isolated from various plants. A lot of these plants are famous for their anti-diabetic properties. So arginine is a polyphenolic. You can see lots of hydroxy groups. And what I'm going to show you is something very There was a cell model, there was a cytokine, and cytokine induced apoptosis was protected by the burgeoning. So you can see a dose-dependent increase in cellular ATP level, which is an excellent marker of cell viability. So probably this molecule in a dose-dependent manner was able to almost to a normal level restore the cellular number and function. And that is an extremely important indication that this molecule is capable of suppressing apoptosis induced by cytokine. This is another very important marker because when you work with the cell physiology, then you really see these fascinating different markers which can tell you about the cell health. For instance, in this case, caspase 3 activity. Caspase is a converging molecule, converging enzyme which eventually trigger the apoptosis. And this molecule, glycine, was capable of decreasing the caspase 3 level in a dose-dependent manner, and that is an indication that so-called extracellular triggering of apoptosis, which eventually lead to intrinsic apoptotic pathway of caspase 3 production, is also depleted in the presence of this molecule. This is mitochondrial cell potential. Mitochondrial cell membrane, mitochondrial membrane potential is extremely important. We understand that diabetes is primarily a mitochondrial disease because mitochondria, in case of diabetes, produce lots of reactive oxygen species, and mitochondria is extremely important. If we can keep mitochondria healthy, we would be able to save cells from so-called free radical induced degeneration. Here you can see glycine was able to restore the mitochondrial membrane potential, which deplete in case of apoptosis. But just in case of, this is the direct measurement of reactive oxygen species, so-called superoxide. And here we can see that molecule budgeting was capable of depleting the production of reactive oxygen species. As a result of it, the mitochondrial dehydrogenase activity has increased, which again is an indication of cell viability. A core theme which is used in anti-TSA. Cellular nitrite is again also a very important reactive free radical, and this cellular nitrite increases in case of apoptosis because apoptosis eventually is the result of a combination of different kinds of insult. So this molecule was capable of decreasing cellular nitrite level, and this is the gold test. You know, if you want to see, if I claim that this molecule is capable of protecting cells from apoptosis and restoring function, then these cells should be able to respond to glucose. So 2 millimolar, 16 millimolar in a dose-dependent manner, the cells protected by glycine was capable of producing insulin. And this so-called glucose-stimulated insulin secretion is the best test of cellular function. This molecule is now published and protected, but I just want to tell you that this is an area if we can all go together because it represents so-called uncharted water in the field of anti-diabetic development. Now, just at the end, in the last few minutes, the objective of my presentation is not to show you in-depth lots of these studies. I had the chances of delivering lectures in KDU, and hopefully you shall have opportunities of delivering detailed lectures, but just wanted to present to you how this fascination of chemistry is really attracting the attention of lots of young people. There were 600 PhDs working on different aspects of chemistry, and this is an extremely interesting area of so-called biotransformation. We chemists know that you can derivatize and change the structure of molecule by using various chemicals, but can you do it by using fungi, bacteria, plants, even parasites and animal cells? This is an extremely important area because What it requires a very simple laboratory. It doesn't really require very high technology lab, and what it requires is just a collection of different fungi bacteria, and it's very simple and straightforward because we use the bacteria and fungi, incubate them in the presence of compounds, and they modify the structure and produce often novel libraries of compounds which are not accessible by using chemical synthesis. So this is an area in which we start working since last 3 years. This is the approach which we have used. Aromatase is an extremely important enzyme which is a key drug target in breast cancer. Whole section is working on aromatase inhibitors, development of aromatase inhibitors, because 3/4 of cancers are because of estrogen. Estrogen is a hormone which trigger the cell multiplication in breast cancer, and depreciation, so-called deprivation, estrogen deprivation is a key approach to inhibit the progress of hormone-dependent cancers. So any cancer in which estrogen receptor are involved, so-called ER-positive cancers of different kinds, this is extremely important to inhibit the production of estrogen. And for that, it is important to inhibit the enzyme which is responsible of production of estrogen. So estrogen is produced in as a result of catalytic function of aromatase, and if we can inhibit aromatase, this is the structure of aromatase, and if we can inhibit the function of aromatase, we'll be able to reduce the quantity of estrogen, and therefore the reoccurrence of cancer or progression of cancer can also be depleted. This is a very important target. There are several drugs available currently as aromatase inhibitors. These are some of the examples of aromatase inhibitors. We start working on it, but we have used an approach of biotransformation because we wanted to produce libraries of compounds which are not accessible by synthetic chemistry. So for that we have to develop our own assay. We purify aromatase enzyme from human placenta. Tons of loads of aromatase available in human placenta, and we also produce it by using dry carbonate technology. So we express them by using molecular biology approach. We have tons of aromatase available now, and this human aromatase is used now as a target for development of aromatase inhibitor. Measurement of aromatase inhibition is extremely simple. It is quantification by using ultra pressure liquid chromatography. We need to measure the estrogen production, and if we see that estrogen production is depleted, it means aromatase activity is depleted also. This is testosterone, which is a molecule already known for aromatase inhibition, and what we have done was that we produce libraries of testosterone by using variety of different kinds of bacteria. For instance, in this case, you can see that this is the fungi that was used, and this fungi was able to introduce an hydroxy group here, and as a result of it, libraries of different compounds were produced. Many of these new molecules were more active than the standard drug exmestine, and this is extremely important because if you try to produce them by using chemical synthesis, often the changes are extremely predictable, and you will find that world literature has many of these derivatives already discovered. So biotransformation is an excellent way of producing often unpredictable and novel analogs of existing molecules. So this is a classical example of using biotransformation for the production of new biological molecules. Interesting aspect of it that we start from bioactive substance. And when we start from bioactive substance, production of molecules which are biologically active is almost ensured. So it's not hit and trial, it's more of an extremely planned way of producing new biological chemical space. And this is what we have done. I won't go much detail of it. We have done lots of fine chemistry on it. We have done crystal structure of that. We have done in silico studies. We have produced these enzymes in large quantities, and now we know exactly where in the enzyme structure they are bound. So lots of molecular biology, structural biology was carried out. What I wanted to present to you today that this is absolutely phenomenal that we should be going into the nature and try to explore this fascinating chemistry which is present in it. Largely so-called crisis in pharmaceutical industry of not new molecular entities not coming is largely because nature has been ignored. And we have decided to go to the basics, and we have decided to work on natural products and to use natural products for a variety of different kinds of drug entities. And for that, the whole paraphernalia of development of biological assays, animal houses, so-called molecular biology, and structural biology facilities, and excellent spectroscopy facility were all developed, but the emphasis remained on nature because we believe that this is nature which gives us lots of advantages over Western pharmaceutical companies because these are our tradition and our knowledge. I'd like to acknowledge absolutely wonderful group of scholars which work with me. They are from different disciplines. We work with a lot of different companies and industries. We have been the largest recipient of industrial support. For instance, we have received to the magnitude of about $2 million from Sun Pharmaceutical Company and other, and they are the real contributors. I just will take you through glimpses of this research center where we have had the honor of welcoming many excellent Sri Lankan scientists since 1970s. And this is the HEJ Research Institute of Chemistry, a very large chemistry center. This is a molecular medicine center. This is a new building which we have added, which is called the World Academy of Sciences Chemical Center. This is biotechnology wing. This is again a new addition in nanotechnology. And we have a very large genomic center, full-fledged genomic center, which is also a national facility for synthetic DNA. This is a laboratory which we have developed in honoring one of our founding fathers, Professor Kotelawala, German scholar who worked with us. So lots of these. This is the new National Virology Institute, which has a BSL-3, a very large BSL-3, which works on viruses. So this is a national facility for viral research. And of course there are lots of animal houses, different kinds. This is our clinical research unit. This is 120-bed hospital for clinical trials. And of course there are technology innovations of different kinds. The facilities in the institute are among the best in the world with 30 superconducting NMR, including 800 megahertz, lots of different X-rays, mass spectrometers, and a whole range of different facilities, including lots of cell physiology and tissue culture facilities, and genomic and computational research facilities, and of course excellent library. I would end here by expressing my gratitude to my dear friend, Vice Chancellor of ADU, Professor Dr. General Melinda. He has been a great friend for all of us. He has visited ICCS several times, and we were able to develop an excellent equation and chemistry together. We also had to work on various projects, and certainly with the presence of the Vice Chancellor of that stature, we will be able to develop a good collaborative model between Sri Lanka and Pakistan, which already has a very good history of working together. With this, I would like to thank you all for your patient hearing. I would be very pleased to respond to your questions if there is any. So
Thank you, Mr. Chaudhary. We're basically taking the questions at the end of the session. There will be 2 more presentations, so the Q&A session will be in approximately 45 minutes. I hope you can stay online, sir. If there are any clarifications that the audience
Okay, I have stopped my slide sharing, and if there is any question which I can understand because voice was not that clear, I would be happy to answer.
Thank you, Mr. Chaudhary. So we're taking question and answers at the end of this plenary session, which will be about another 45 minutes time. I hope you can stay online to clarify the questions if there are any, because there are 2 more presentations, and at the end of that we shall take the questions.
I cannot hear you. I'm sorry.
Can you hear me now, sir?
Yeah.
Okay. The way we have set up this session is there are 2 more presentations, and we are taking questions and answers at the end of the plenary session, which will be in about another 45 minutes time. I hope you can stay online at that time to clarify any questions audience may have for you.
I'll be happy to. I have to leave at about 2:45. Still have about about 40 minutes or so.
Yeah. Thank you, sir. Thank you very much for that presentation. Ladies and gentlemen, we will move on to our second presenter. Our second presenter is Dr. Kotelawala. He's the Director of the Resource Management Associate, which extends consultant services on energy development projects in Sri Lanka as well as many other countries in South Asia. Dr. Kotelawala is an engineer by profession, and he has promoted energy efficiency and promoting affordable energy in Sri Lanka. He's been a well-known critic on our energy policies, and he has contributed immensely to the dialogue as to how we should tackle our energy challenges in the future. Dr. Kotelawala will be giving his presentation also online. Over to you, Dr. Kotelawala. Dr. Kotelawala is having some technical difficulties to connect into this session, so we will take his presentation subsequently. I'm going to ask Dr. Kotelawala, who is with us today, to go next. Dr. Kotelawala is an independent energy analyst, has been a strong proponent of energy security and increasing use of renewable energy, which is one of the major requirements in our path to sustainability. He's a very young person, but has been very versatile in his energy field. So may I invite Dr. Kotelawala to come and give his presentation.
Good afternoon, everyone. Thank you, Dr. Devakat. I'm going to talk about renewable energy, and I think this resonates well for today's theme, which is also about security and sustainability. So question we have to ask is, there are certain drivers that have moved us very fast towards the renewable energy future, and one of it is climate change. And I'm showing you this image. This is Hurricane Dorian. Now, what's interesting is that this is a Category 5 hurricane, and it's stayed on top of Bahamas for 24 hours. Literally standing still. And then we know this, that two things we know about hurricanes, that their strength increases, and the speed that it moves across either land or water actually decreases. So there's nothing you can do to a Category 5 hurricane. It's on top of your country. And what Bahamas said is that this is a generational damage. It will take a generation for them to recover, if they recover at all. This is 2 months back. This is the Golden Gate Bridge of San Francisco. And what you see here is the glow of the wildfires that's currently burning in the west coast of California. So from the coast of the US, from California all the way to Washington State, and even a little bit more inland into Colorado, as in some pictures today. We're talking about something like 3 million hectares of forest that's going to get burned out, and probably more by this time. So, and we saw similar images in Australia during last December, January period, and we are looking for another version now. This is what climate change is actually creating to us. And, the image, we know that 2019 was another record year for carbon dioxide, and it was also 1 degree more on globally compared to 1950, 1980 baseline. And the image on the right shows how carbon dioxide levels have increased throughout a period of about 800,000 years. We are in an era where, as a civilization, in a particular stage in our civilization, that our civilization grew in a space where we had climate stability and we have prosperity. The people who seem to be most active about it is not people like us who have the power to make change, but kids, school kids, and they are the ones who are actually going to make this change happen. So, if you don't talk about climate change, and I think of engineering as not a technical profession, but technical profession that responds to a larger global context. So if we are going to talk about energy without talking about climate change, which is the most critical problem of our times, then we have lost the problem. That's not engineering in my opinion. And we know that the world is responding. This is last year's projection by Bloomberg, where the fossil fuel as a percentage of energy in the world is reducing. What's interesting is that every year you look at the projection, the way the fossil fuels actually reduce is becoming more fast, right? So yesterday, International Energy Agency issued their report, and they basically said the percentage of coal in the energy mix by 2040 will be less than 20%. This is something that a few years ago nobody thought would be practically possible, but that's the trend. When we look at Sri Lanka, we have, unfortunately, CB doesn't want to let go of their fossil fuel addiction is a word that I may use very, very thoughtfully. This is the 2018 plan on the right hand side. You see a heavy amount of coal and gas. Now the new plans just shift the coal and gas, and it's still very fossil fuel driven, and that goes against what everybody else is doing. Then there's a question about energy security that comes up. Now, this is a defense university, so I cannot not speak about energy security when I come here. The challenge with fossil fuels is that funding for fossil fuel development, especially coal, as well as insurance, is very, very rapidly dying out. Japan, one of the big banks in Japan, are financing coal anymore. Even the large financial institutions, I think Europe, US, even Korea, Australia, some of the mines are struggling. And financial institutions and insurance organizations can actually take coal out, and that's what's happening in the last 3 to 4 years. So the decline of coal is likely to be very, very rapid. So as a country which does not have our own coal, more dependent we become, we run into a risk. And it doesn't improve just because we have a little bit of coal and a little bit of gas. None of the fossil fuels that we use are actually indigenous. So this is a picture of Kotelawala. The government is planning one more 300 megawatt expansion, which is, according to CEG, supposed to come in 2023. And if it comes in 2023, it will produce 50% of our electricity. Now, the problem with this is that it's one location. There is one jetty, one unloading bed, which has to work 6 months to make sure that we get enough coal for the whole year. So, if this is not an energy security risk, I do not know what it is. So, unfortunately, energy security is not something that is very, very seriously talked about. Sustainability also is not something very, very seriously talked about in Sri Lanka, and that has to change. So, the President's target was 80% renewable energy by 2030. And we had some sessions. I represent National Agenda Committee for Energy in the Sri Lankan Chamber of Commerce. So we brought in probably the 3 best power system specialists of Sri Lanka. President Plenary from Moratua, Dr. Narendra from Moratua, and Dr. Ashwin, who was a Moratua graduate but who runs an institution in Canada. And consensus is that there are no technical barriers to achieve 80% renewable energy in electricity by 2030. However, this has been very fiercely opposed by CEB, who's our monopoly utility. And this target of 80% renewable energy by 2030 is not something completely different to some of the countries that are having now. That's the whole of EU last week committed to reduce emissions by 60% compared to 1990 by 2030. That means that grid can have, whole of Europe can only have 20% electricity coming from fossil fuels, 67% renewables, 13% nuclear. There are 10 Latin American countries who pledged last year to have 70% of their electricity coming from renewables. And there are other countries as well. And every year, more countries join this. So what we are trying to aspire is not unusual from a global standpoint either. And that's not technical barriers as well. What's happening in India? So India is quite interesting. As you can see, it's the generation plan. But the scale of their target is amazing. 60 gigawatts of rooftop solar by 2030, 300 gigawatts of solar, off-grid systems, 140 gigawatts of wind, and battery storage. So India set a target to have 175 renewable energy by 2022, set in 2016. They will probably miss it by 1 year. And unfortunately, we talk a lot in Sri Lanka, but we don't build. So we have lots of people talking, including me, but I think that's really built. The third driver of this transition, the second driver of this transition is actually cost. So this article that you see on top is from the International Energy Agency's latest report. They do annual report, volatility outlook. Basically says by 2025, coal is cheaper than any energy source has ever been in the world. Solar. And coal is no longer cheap. in any major country as a new construction, and in most locations, all existing coal plants are also not financially viable compared to new renewable energy. And the picture at the bottom is Lazard, where they clearly say the same thing. Some numbers. So the last tenders in Sri Lanka, the newest ones, solar is around 9 rupees per unit, wind is 950, natural gas is expected to be 15, coal is expected to be 18. Now we have about a transmission and distribution cost, I think Dr. Sibaratti is going to talk more about it, it's about 4 rupees. But our selling price is 1650. So if we want to keep our tariff constant, we cannot do this by building coal or gas plant. It can only be done from a cost point of view by building large-scale renewable energy. The Indian prices is much cheaper. India coal and wind comes about 7 to 3 lakh rupees per unit, and with storage comes around 11, between 9 and 11 rupees. So these are numbers. If you build in similar scale and similar price, we can survive the next 10 or 20 years without having to increase our electricity tariffs, even though the dollar keeps escalating. And why is that important? As you can see, the graphs that are going up is that, the standard would be depreciates by about 4% per year. So anytime you invest on a fossil fuel power plant, it forces our electricity cost to go up. If we want to keep electricity costs low, we must invest in renewable energy, and this is how other countries are also keeping and lowering the energy cost globally. The third part of what this transition is going on is actually a technology-driven transition, because renewables are cheaper on one side, and the way we use energy and way we produce energy has also shifted. So traditionally we used to have large power plants generating electricity at a centralized location, and transmission lines and distribution, which is what you can see on the top. But by now, the new paradigm is about small-scale distributed generation, where the transmission and the large power plants play a smaller role. And this transition is happening all over the world, and I will explain some of it how it's happening in other countries as well. So, do we have enough power to power the country from renewable energy? So Sri Lanka right now has some of the world's best onshore and offshore wind zones, which is a picture that you see on the left-hand side. The reason is that this type of a high-performance wind zones, everybody else has already built the plants, and we haven't, because we have been blocking the power plant from building. So we have close to over 10 gigawatts of power from wind that we can build, and we also have very high solar zones, which you will see in the right-hand side. Now, one of the problems with solar is that we actually don't have enough land space, and the alternative for this is floating solar, which we can leverage on existing lagoons and reservoirs, so we do not compete for land with solar. And here are some of the ways that we can connect, because we have our transmission grid connecting, going very close to large water bodies, and building this will be much faster than building any fossil fuel power plant, and cheaper. And even our wind pattern has particular variations that we can leverage. We do have certain times of the year, which you can see from here, where the February, March, April, and October, November are low wind zones. So the trick is how do we plan generation where we manage to have other ways of supplementing our energy needs during the time wind and solar are less prevalent. We've done some modeling on how different power sources will power the national daily demand. But the simple point is that we can do this. The only question we have to ask is that how much of fossil fuel plants we need to have reserved. Okay, for a period where there is a longer period of no wind, we will need to use certain amount of fossil fuels. That's the only question. Question is how much fossil fuels we need to have, as opposed to not whether 80% is possible or not. It requires us to change how we operate our grid. We have a day-ahead dispatch. It has to go down to 15 minutes or 30 minutes. This is happening all over the world. We have changed our dispatch model. Right now we use hydro as energy generation. But hydro in most countries are now shifting to manage the variation of generation of solar. So when there are clouds, when there is less solar, the hydro will ramp up, and when the clouds go away, hydro will go down. So it's a regulatory function as opposed to generation only. And battery and pump storage are quite cheap now, and that's also possible to balance, especially in the night. So people say there are lots of problems. There are voltage issues, inertia, intermittency, seasonality, night peak, system stability. I'm not going to get into the technical side, but these are technical and engineering problems with commercially viable and already implemented solutions globally. And the way a lot of countries move is by using predictive technology to understand how the wind and solar variation. Now, India set up 13 renewable energy management centers for each state, which gives the predictive capability half an hour earlier about how much solar generation, how much wind generation is going to be. That allows them to plan and run the grid without interruption. There's quite a lot of studies that needs to happen. Australia has done it, Britain has done it. And we are already seeing quite a lot of solar and wind penetration at instantaneous levels in the grid now. So the picture you have is or one back in Germany, where solar and wind provided 72% of electricity at a given point of time. Here's something in Australia where a couple of days ago, solar electricity provided 100% of the energy required in South Australia. So, we are talking about having about 5% of our electricity coming from solar and wind, and our utilities scared. Right? Our utilities scared of rooftop solar. In Australia, which has a lot of coal and gas, 1 in 4 households have rooftop solar. In some states like Queensland, which is the biggest coal hub, 1 in 50% of the households have solar. Right now they have 13 gigawatts, and this is likely to be the most largest contributor to energy, and their installation of solar rooftops is not reducing. They are building this year, they will build about 3 gigawatts. We can only build about 70 megawatts, even though we have the same population. So they are just not doing the trend right. The question that is also coming up is that because of the way solar and wind work, because there are not steady power supplies, there are shifts, there are changes, there is intermittency, keeping the grid stable has become a concern in most countries in the world. However, and this is one of the reasons that I've been hearing from our utility CEP, grid stability is very important, it's very, very expensive. But the study is, this is a study that was done in India, the actual cost for grid stability upgrades is actually marginal compared to the cost of electricity. So this is not a problem. And the equipment is there. So this small-scale power reserve, I think people know this as Tesla big battery, which was built by Elon Musk in South Australia in 3 months. And it's doing all the stability work for the South Australian grid, including something called virtual inertia or synthetic inertia, which was believed to be, it's a particular function, it's something you have when you have generators which have large rotating masses, but it's now replicable with electronics with battery storage as well. So there is no hesitation to go down this road. And the second concern I've heard from our utility is that, when we talk about Australia or we talk about Europe, these are larger grids that are interconnected through multiple states or multiple countries that really have a highlighted grid. But South Australia also gives us an interesting perspective because South Australian grid is actually the same size as the Sri Lankan grid. During this year in February, they are connected to other states and this connection basically broke down. And they ran in an islanded mode with very high renewable energy penetration for a period of 2 weeks, and their complete system was stabilized by the Tesla big battery and another 30 megawatt battery. So these are not problems that are not solved in other countries at this point of time. And there are innovations. I'm just going to show you two because I think I tie this up. One is a virtual power plant. This is networking of 50,000 households. Each household has a rooftop solar system and a battery system which mimic the function of a power plant. So these things are very easy to do. And this is another interesting idea that's coming on, something called flexible power plants. These three companies, Lanjam, Social Energy and Electricity, are all UK companies. And what they do is that you can imagine them as Uber or Picnic, where anybody who has an energy asset, that could be a generator, that could be a battery storage, we connect to the network as a service, and this company offers the same service to the national grid to be used during a power failure or a grid failure, so that it pumps in electricity, or when something other happens and it needs to absorb it, it can also absorb it. So these are kind of innovations that's coming. What I want to close this session is that we had a period where we were using landlines and dial-up phones, and now we are using this smartphones, and it affords us kind of services that we never thought of. How we use them is very, very different now, and that's the disruptive transformation. And that type of a disruption is what's happening in the electricity sector, driven by technology and renewable energy. We have two choices. Either we stay in the last century, or we do the same transformation that we do as Sri Lankans also in the mobile technology and apply the same in the electricity. That's it. It's a very stark choice. And financials, technology, and sustainability and energy security all point to this location. Thank you.
Thank you, Dr. Anandan. I think we can now go to Dr. Sivalapiti's presentation. So it's a slide issue. You can't hear me from my chair table. I already gave introduction to you 3 days ago, but you could not connect. So the audience knows you have already been introduced to the audience, so you may continue. Thank you.
All right, thank you very much. Let me first share the screen with you. Well, it does not seem to allow me to share my screen. Somebody would have to relieve me. Sorry, it does not allow me to share my screen. Alright, seems to be okay now. Thank you very much. I believe you hear me. Otherwise, please do let me know. The subject given to me is the national electricity grid, immediate needs and future directions. So over the next 20 to 25 minutes, I plan to take you through particularly the immediate needs of the national grid, both technically and financially, to ensure that the grid becomes not only technically stable but financially stable as well. Because without financial stability, nobody would be able to handle the large-scale development as well as the significant transitions that we expect the grid to undergo over the next decade. So briefly, I will be introducing the electricity industry structure and the challenges faced by the Sri Lanka electricity industry and efficiency improvements and standards, and about distributed generation and the role of the grid. So that's the outline of my session. So for the benefit of those of you who are not particularly familiar about the electricity industry, and as we know electricity industry, what we have is a regulated electricity industry, and most of it is owned by the government directly or indirectly. I'm not going to go through details of this diagram, but only to highlight the fact that the Ministry of Power is the policy maker on behalf of the government, and the government is the owner of much of the generation that is owned by CEP, and all the transmission that is owned by CEP, all the distribution that is owned by CEP, whereas the fifth distributor level is indirectly owned by the government through various other agencies. Then we have the Public Utilities Commission, who is the regulator. There are private power producers who are known by the acronyms of IPPs and SPPs. Then promoting and regulating the renewable energy use as well as energy efficiency is the responsibility of the Sri Lanka Sustainable Energy Authority, and all these agencies and institutions are expected to provide a reliable supply to us, the customers, at the optimal costs. So that's really the objective of all the legislation and policies and technologies and institutions are supposed to be doing, to look after the customer. So what are the challenges? This is briefly, in my view, the challenges which will have to be resolved as we go on. So not only one of them will be a challenge, in fact all of them are challenges, because these are the expectations of the customers, the government, the society, and the world at large. The question of inadequate generation. If I show you this diagram, you might say, look, the orange line is at 4,210, and the black line that shows the demand is only 2,616. But if I tell you that 50% of the installed capacity is renewable, some with storage and others without storage, and even the storage in hydropower plants are linked to the irrigation and water supply system, where water supply for drinking and irrigation have the priority, power is the third priority. Then there are more constraints that have to be faced by the Sri Lankan renewable energy supply system than some of the other systems elsewhere in the world. So there are many constraints even to operate the storage hydros that we have does. But as I'm going to tell you later, none of these constraints are firm and solid. Any constraint can be met with enough and adequate and additional investments. So right now, the problem we have is excessive cost of generation, and there is immediate need to arrest the situation. So this is the group of generating technologies that we have been using over the last few years. I would not say this is something that anybody expected, particularly the yellowish band of oil-fired generation. There is no country that does not produce oil. Even the countries that produce oil, they do not use electricity to produce, say for example, in 2012, 60% of electricity. In 2018, almost 20% of electricity. Most likely last year, about 25% of electricity. So this is an abnormal situation, and the reasons for that, of course, we can discuss, but I will not take your time at this moment as to what the situation, why we can work on this kind of a situation. These are the costs and the prices approved by the Public Utilities Commission. I've gone back to years 2014 to 2019 because in media we hear very frequently that the electricity industry is running at a huge loss. So this is information about the costs of electricity production, which I have divided into two: the capacity cost and the fuel cost, as approved by the Public Utilities Commission. Of course, when I say fuel cost reflects the production costs that are directly proportional to the electricity that is produced. So these fuel costs, say for example 1392, is the weighted average of the fuel cost in the coal-fired power plants, oil power plants, and electricity purchased from renewable power plants, electricity produced in CDB's hydropower plants. So all of these put together, the weighted average is 13.92 as approved by the Public Utilities Commission. Transmission cost for a unit of electricity sold. Now don't forget, this is cost per unit of electricity sold. So the calculation is relatively simple. If there is a fixed cost to be paid for electricity generation, whether it is CPO or private power producers, if there is any fixed cost that is not proportional to the amount of electricity that it produces, that's fixed cost. Divided by the amount of electricity sold in 2018, the answer is 312. Similarly, the other figures, the transmission, the distribution. So the approved cost of electricity production is 12%, rupees 2159 in year 2019. And the same Public Utilities Commission has approved the electricity selling prices. So the selling price in year 2014 was 18 rupees 94. And as you know very well, elections approached at the end of 2014. A presidential declaration from an election platform for the electricity prices to be reduced. From 1894, it worked out to 1629 in year 2015. So therefore, Public Utilities Commission went along the presidential declaration and said yes, electricity price should be 1621, whereas the Commission told the approved figure was 1889. So thereafter, these were the approved cost of supply, these are the approved price. So therefore, obviously, as you see, the gap has been increasing. So therefore, the electricity industry has got into a very large financial deficit. So, who should pay this difference? Who should pay this difference? So one might say the government, isn't it? The government should pay the difference. Now, who is the government? The government is us, nobody else. So it will be the population who will have to pay the difference. So I tracked the costs of supply of electricity to different customer categories because we need to find out where the subsidies are going. So take the cost of supply and then disaggregated according to the customer categories. So basically, technical definition of customers is bulk customers at medium voltage level, bulk customers at low voltage level, and the retail customers who are shops, supermarkets, the smaller commercial customers, and the households. So as you see, as you go downstream of the network, because there is no distribution cost to supply to the bulk customers, there is no distribution cost for these people as well. There is a distribution cost for this group of customers because they are downstream of the distribution network. But because they are not big time customers, the cost of producing and supplying a unit of electricity to these customers is smaller than household customers. So household customers as of 2019, according to the Sri Lanka electricity costing model, cost 30 rupees to supply. You can go home and look at your electricity bill and find out how much was your electricity bill for a unit of electricity last month. And for most of you, including me, the cost of supply is less than, or rather price of supply is less than 30 rupees. So they like that the price of electricity to different customers, which very clearly says that there has been intentional or unintentional subsidy to large electricity customers as well, to the tune of about 2 rupees 50 cents for a kilowatt hour. And for the smaller, the larger bulk customers, it's about the same, no subsidy, no surcharge. But for other retail customers, there is a subsidy, as you see. And for household customers, as a group, you and I, in our households, your neighbor, and the house in the remote village, and the luxury house in Colombo, we put all of us together, we pay only 50% of the cost of supply. So this was the true situation in 2019. Of course, depending on how you model and the way you make assumptions, there could be small changes here and there. But this is generally the picture. So, what do other customers pay in their own countries? So here I compared household using 90 kilowatt hours. Now why I selected 90 kilowatt hours per month is that's where most of our household customers are. A substantial percentage, approaching 50% of our customers use less than 90 kilowatt hours per month. So their electricity bill works out to about, my vertical axis is in US cents per kilowatt hour, about 6 US cents, whereas as you see, even some states in India, definitely Thailand, and even Philippines, who is on the per capita terms having the same GDP, similar GDP like Sri Lanka, charges a lot more from household customers than Sri Lanka does. So, what I'm saying with this is that we are not the country with the highest price of electricity, as it is being told many times, particularly on political platforms. Same comparison for commercial customers. Again, I selected fairly large commercial customer. Say for example, maybe a supermarket or a large office building. Sri Lanka is on the high side, but Maharashtra, India charges more, and Tamil Nadu charges about the same, whereas in South Korea it is cheaper. In Bhutan it is cheaper. So, and Vietnam also is cheaper. Industrial customers, again our industrial customers pay less. I selected the industrial customer in the medium range when it comes to industry, and they pay about 10 US cents per kilowatt hour, whereas if you were in India, you have paid about 50 US cents per kilowatt hour. So, of course, the reasons for why these things are happening are many. And those reasons can be traced. Of course, we don't have time to go into all these details in this 20-minute presentation. But there is a lack of implementation of the plans. And there are disputes about the plans, the regulator and the utilities are disputing each other's calculations. So the end result is not that renewables are not done. In fact, no power plants are built. So therefore, Sri Lanka has had to rely on more expensive power plants, most unfortunately. meet the electricity demand, particularly over the last few years. By the time we reached year 2014, the share of oil-fired generation was 14%, and it was planned to bring it down to 5% by this year. So that did not happen. As I said, it's already increased to almost approaching 20% this year. So another challenge, reliability improvement. Again, not trying to go into a lot of details. As you know, we have had 5 blackouts. I'm not going to go into a lot of details, and as you see, the total time to blackout in each one of them. The first one in 2009, only 5 blackouts in the recent memory. We have had a lot more blackouts before, only 5 blackouts in the recent memory. We had only 3.5 seconds before the grid went black. Then of course, the next one 3.5 minutes, and in February 2016 we had 8 minutes. The most recent one was most severe, in 2 seconds everything was dead. So there is a need to improve the strength of our power system, because our power system can be classified as a weak power system from many aspects: the connectivity, the capacities, the information that is available, in many aspects, the stored energy, all the many aspects of our system can be classified as a weak system, which in fact at this moment is the largest generator use. There will be some customers who will be automatically removed from the grid. You don't find this in any of the larger, more stable power systems. That's one indication that our power system is still weak. It needs to a lot of improvements. Electricity pricing reforms, and there are issues related to household electricity pricing, as I have listed on the left-hand side. Everybody wants electricity at a low price and if possible free of charge, and everybody wants solar PV to be connected to the grid and pay a zero bill. So therefore, in theory, if everybody has a zero bill, then there is no money to pay for backup capacity and for the transmission network and the distribution network. Because as we know, we are still not, the world and Sri Lanka are still not ready to go back to distributed generation and to dismantle the transmission and distribution network. So everybody wants a grid, everybody wants a grid connection, but nobody is willing to pay the price. However you calculate is detailed, but people have to agree to pay the price, pay the cost of services. Sector reforms have been complete. The beautiful objectives that were there, that the efficiency of the electricity utilities will improve, and pricing will be cost effective, and customer categories and the pricing will be simplified. So none of these things were fulfilled by the utilities, by the governments, and by the regulators. It's not one party, but many parties who have not fulfilled the beautiful aspirations and statements in the policy documents we had 10 years ago. So I think I will move on quickly out of these slides. I will move on to from safety to commercial regulation to the constraints to renewable energy development. So once again, I am not saying these constraints cannot be overcome. The constraints can be overcome, but everything needs strong policy guidelines and the willingness to stick to the policy guidelines, and of course willingness of everybody to understand the strengths and the limitations of renewable energy, as well as the willingness of everybody to pay for what it costs. We will move on. We will also move quickly through energy efficiency improvements. There are quite a number of achievements. The Sri Lanka's low profile has improved very substantially over the last 10 years. since the time of use pricing for all customers except for retail customers was made mandatory. So 10 years ago, electricity pricing was adjusted in such a way that for large and medium industrial and commercial customers, electricity is more expensive during the day and even more expensive in the evening peak period. So today you will find when you walk into a commercial building, they are sensitive to the price, and by 6:30 p.m. they will be running around switching off unwanted air conditioning systems. So that is good. That has allowed Sri Lanka to improve the national load factor from 55%, where it was standing for a very long time. For decades, our load factor was at 55%, and last year it recorded 67%. So that means, as a combination of many things, this is not the only reason, as a combination of many things, the asset utilization, that's what the load factor means, the asset utilization has significantly improved. But we expect the load factor hopefully will reach about 72% in a decade from now. So there are good things happening, everything is not lost. I'm not having a slide on the network losses. 20 years ago, 20% of electricity was lost. Last year, it was only 8.4%. Sri Lanka is working on 7.5% network loss for next year. But sadly, I think we are going to miss that target. But I don't mind, we have been improving. But there is a lot more scope to improve the network loss levels to a possible target of 7% by 2030. So saving the last bit of energy is difficult, but it can be done if there is a will, and also good monitoring, good analysis, and focusing on where the last 1% of electricity can be saved from being lost in the network. Of course, there are emerging challenges which are many. Let us take only one challenge, distributed generation, which of course is all renewable. And what is the role of the grid in managing distributed generation? So, the grid was designed as traditionally a centralized network where power flows from one direction towards, that means from generation towards customers. Now, the distributed generation is bringing electricity production or causing electricity production at different lower levels of the network. In the early days, actually generation was distributed. City of Kandy had a generator, which was managed by the municipality. And they had a local distribution network. They would, in a remote town, the generator will be run only for 4 hours a day, 6 p.m. to 10 p.m. So that's how the Babula municipality was providing the electricity supply. Not so long ago, even in 1940, this was the situation. There was no national grid. City of Colombo was similar until about 1950. But City of Colombo electricity generators were large, so therefore customers did not know where the electricity is coming from. Then of course, gradually the national grids developed. Why? Large generators are more expensive to build but cheaper to operate. So therefore large generators are more stable. Therefore, and they can take sudden changes in customer demand up and down. So therefore, large generators were seen to be the best option as seen a century ago. Then of course their investment was higher and the operating cost was low. So therefore, the bigger the better was the thinking, and Sri Lanka was special because hydropower resources were far away from densely populated areas of economic activity. So therefore, having a national grid and long transmission lines were inevitable. So we had a national grid. Now we are going back to a substantial injection of distributed generation. And Sri Lanka started off with allowing distributed generation from 1996 to be connected to the grid. I'm happy to have been part of that team that made those decisions and wrote the profits from mini hydro connected to the grid. So that's the first entry to distributed generation that we had in this country after the national grid evolved starting from 1950. So looking back, 1950 to 1996, we had virtually a fully centralized power generating system. But that's not to say, for example, the town of Plenary never had the national grid before the war. The town of Mena had a diesel generator until about year 1990. So some towns in the country, the national grid was a dream which was only recently fulfilled. But now, the advent of renewable energy, particularly mini hydro starting off the trend, and from 1996, these are some pictures, has made it possible for more electricity to be produced and increasing the amount of electricity to be produced at the distribution level. So these small power producers are connected to the grid at the distribution level. So the status as of 2019 is that there were 206 mini hydros, 15 wind power plants, 27 biomass and solar parks, and more than 20,000 household customers who are connected to the grid on LV side. So the famous picture as to what a net metering system would be for a household. I will speed up. I know I've taken my 22 minutes already. And as you know very well, there are 3 schemes operated to provide opportunity for households and anybody who owns a building to inject electricity to the grid. And electricity is purchased from these renewable energy sources, of course in this case all solar PV at 22.50 per kilowatt hour. Now does that ring a bell? 22.50 per kilowatt hour from the rooftop, whereas the national average selling price is about 16.50. So, of course, that's not to say that there are other forms of electricity production that cost even more than 22.50, which we are still running because the lower cost electricity generating capacities could not be built for various reasons. So, obviously, these renewable energy costs and prices are coming down. So it takes some policy review to make the adjustments. If you look at this number 20 years ago, the answer was 45 rupees at that time. If you looked at this number 10 years ago, the answer was about 35 rupees 10 years ago. But by 2014-15, prices came down substantially, so therefore the calculation came to about 22.50. But as we know very well now, between 2016 and today, simply across the 4 years, the equipment costs have come down substantially, so therefore these prices will have to be adjusted. So, I will skip this picture. This is my last slide. There are emerging challenges because I said there are many challenges that I can only explain one. The rooftop solar PV program is catching up very fast and it's bringing in technical challenges which needs to be resolved at the distribution level. So what you see on the right hand side are measured voltage profiles where the low voltage customer voltage in the network in the suburb of Colombo is persistently going above 244, which is the legal limit. Now why does this happen? Because in this suburban network, which you see on the left hand side, there are many customers who have taken the government's offer to have solar PV rooftops, not only to meet their minimum requirements, but to sell their surplus to the grid. So what happens? Remember, the grid was designed to take power from top to bottom in my diagram, that is for generation to customers. Now we have electricity being injected on the designed going in the reverse direction. And the low voltage network has not been designed to do that. So these challenges are emerging, but that does not mean that there is no solution to this problem. Now what could happen if we just allow this to happen, get more and more solar PV customers coming in the middle of the day, the voltage will rise to 50, to 55, to 60. In fact, unofficially we know there are certain networks which are already reported 260. So you may not be a solar PV participant, but your neighbor could be, and the equipment in your house are being stressed. So what are the solutions? There are solutions. Of course, as I say, all engineering problems have solutions. The only thing is that provided the customers are willing to pay for those solutions. So therefore, solar PV would be getting cheaper. In fact, wind capacity is also getting cheaper. 14 years ago, when we debated the capital cost of wind power, here are we talking in terms of dollars. The cost was $1,800 per kilowatt. $1,800 per kilowatt to install a wind turbine. The most recent bid that CEB closed for their own power plant was 1,300. So it's already down to 60% of what it was 15 years ago. The reduction in the cost of solar PV has been much faster. So therefore, but these sources, unlike the traditional sources for which the grid is designed and for which the customers are used to, have certain limitations. If the grid evolved in the reverse direction with distributed generation from solar, and then the central generators had to be brought in to support or to provide the backup power, then the story would have been different. So therefore, to meet the challenges of the limitations, there are solutions. There is, I would dispute that basically the grid can have more renewables, but then those challenges have to be met with the variety of solutions and the customer's willingness to pay. So whether it is UK having so much of wind energy, the electricity bill in UK is several times more than a customer in Sri Lanka pays. Similarly in Australia. So therefore, if we look at the solutions and look at the costs, and then if the customers are willing to pay those costs, then it is not difficult to move forward with solving the immediate as well as the longer term challenges in the electricity network in Sri Lanka. Thank you very much.
Thank you, Dr. Simulavidya. I hope you will stay online for the Q&A session. I'm going to open up these questions. People who are joining us in this room. Can you hear me, Dr. Simulavidya?
I can hear you.
Thank you. So there are people in this room as well as people joining online. So you will present your question either using the microphone, those who are online, and others in the hall can ask the questions directly. We have a few minutes for Q&A.